In this video, we're going to be looking at pulse measurements using a FieldFox RF analyzer, and we'll use both the pulse measurement mode and the spectrum analyzer mode. I have a signal generator set up, center frequency of 3 gigahertz, and I've got a pulse on with a pulse PRF of period of 1 milliseconds and a pulse width of 1 microsecond, a pretty low duty cycle. So let's start looking at this pulse first with the pulse measurement mode. This mode uses the external power sensor, the U2021XA, so I have that hooked up to my SIGGEN. Well, my SIGGEN goes to a splitter and then. So let's see if we can see this pulse. We'll set up it to, for example, 2 millisecond time to see if we can see it. It's a pretty narrow pulse. What would be helpful is if I change the resolution to high, so it's taking more data points. And there is the pulse. You can see it here, and you can also see it here. Sometimes it's also helpful if you're making narrow pulse measurements. Where is it? It's to change this qualification time to 20 nanoseconds or lower to make sure you capture the pulses. So there's my pulse. I can go ahead and turn marker analysis on, and it gives me the data for the pulse. It's giving me an average of minus 33 dBm, peak of minus 7, peak of minus 7. Makes sense because I have 0 dBm at my source and I have a 6 dB power splitter and about probably a dB of loss in the cable. There's my 1 kilohertz PRF, and this 995 nanosecond is close to my 1 millisecond pulse width. You can also kind of zoom in on the pulse closer. If I change this time, for example, to 40 microseconds, I should be able to see, or maybe even let's make it smaller, see my pulse better. Let's make it even 10 microseconds or 2 microseconds if you want to be able to really see the pulse. So you can make this pulse measurements in pulse measurement mode using the power sensor. Another option you have is to go into the spectrum analyzer mode. And in spectrum analyzer mode, we'll set the center frequency to 3 gigahertz. And let's do a frequency span of 10 meg. And I'm not seeing the pulse here right away. What I can do is if I drop down my res bandwidth to 1 kilohertz, looking for the sync function, you can sort of start seeing the sync function here. I can go lower and I can capture the sync function. But the peak power here is around minus 70 dBm. This is pulse desensitization. And I know it's supposed to be around minus 7. So what can I do? I can widen the bandwidth. Let's actually go to 100 kilohertz. And then I can use what's called sweep acquisition. And this is essentially slows the measurement time. We don't have sweep time in non-zero span, but we have sweep acquisition. So you can set that. I can even set it higher. And now I'm getting closer. I'm still not up to minus 7, but if you want to just kind of see the nulls in the pulse, you can make this measurement in this mode. You may be able to also use video triggering. It doesn't always work well. It's sort of you have to try a few things, and when you use the knob on the box, it's sometimes easier. Yeah, video triggering doesn't quite work. Maybe if we can narrow the bandwidth. You get if you narrow the bandwidth, you're slowing it down, you're seeing it. So the video triggering didn't really help us in this case. You also, if you want to look at this pulse in zero span, you can do the same thing with zero span. Oh, and I've got the trigger set up to video, so let's go to free run. And now let's change the sweep time to 2 milliseconds. Okay. Oh, but in zero span, I want the bandwidth to be the widest to pick up my pulse. And our widest bandwidth is 5 megahertz. So there's your pulse. You can see it. 2 milliseconds, so we're swinging 2 pulses. I can narrow this down to 20 microseconds. And if I go into trigger position of 4, then it should auto trigger on. Let me extend the time. Let me troubleshoot here and see why this is. Extend the time. Let's make it 1 millisecond. So there's my pulse. Okay, now I'm going to do a video trigger. And we can even move this up a bit. Now I'm capturing my, now I think if I take my sweep time and lower it, I should be able to see my pulse. Yeah, I just had to get the triggering right. So this is about your 1 microsecond pulse that you're seeing. And if you put a marker to peak, um, marker to peak, around -7 dBm, you're able to capture the peak of the pulse and see the shape of the pulse. So in zero span, it's a lot easier. If you're looking in non-zero span, it's harder to capture very narrow pulses. If they're wider pulses or higher duty cycles, that's easier. So really, there's 3 ways to look at the pulse. In this mode, in non-zero span mode, and here again, we may want to use the sweep acquisition functionality as I demoed sweep acquisition, which essentially slows the measurement down. Oh, and I need to get rid of the video trigger. Go back to free run. And, I can turn auto trigger off. I'd have to increase my sweep acquisition even more to try to capture this pulse. We did this earlier. I'm trying to see exactly how we did it. You have to kind of play with the settings to capture the pulse. It's more difficult. Or the other option is to use a pulse measurement mode. So in terms of optioning, this pulse measurement mode, is an option. So you would need to buy the option for pulse measurement and also buy a peak power sensor. This basic spectrum analyzer mode is available. There is a time gating, FFT gating setup. If you plan on using gating, that also has its own option. I believe it's called option 238 spectrum analyzer time gating that allows you to do this kind of a time gating. It would make more sense in zero span mode if you were using gating. That's it.